today is on a very interesting topic, that's greywater. And greywater, what I learned from Emmanuel, I'm not going to take any credits from him, but he told me the Indian government allocates $2 billion per year for lake treatments. And that to me is something where we, that sounds like a great opportunity, with $2 billion for investment. And of course, it comes with a lot of ifs and buts, but it means there's money available from the government. There are also a number of organizations involved in it, but we could also think about CSR, we could think about local government, TNC will be mentioned. So it is an opportunity, but again, it's for you to look into what the opportunity is and for you to identify something. And what we want to do is post the presentation, be as open and ask as many questions as you want, because the experts are there. And this is really a golden opportunity. Whatever doubt you have, please raise it. Whatever ideas you have, please voice them. And there are no strange questions, there are no silly questions, there are only good questions. Any question is a good question. Any idea in this setting is a good idea. It's to help us form ideas, and what better to have ideas from experts. Now, Emmanuel was again very modest. He's always modest. He's really one of the people who started this whole greywater nature-based treatment in India. He's one of the first who actually went into this. He's been doing it on a commercial level. He's been doing it with big entities, the Dutch and others. So it's really a privilege to have him. And of course, I shouldn't do injustice to Abhijit. Abhijit has also worked and taken this topic to heart. So it is something, for me, normally, if Abhijit sees some value in something, I know that it's there. So, Dewey, I put it back to you after this. So, once again, at the end of the presentation, please feel as free to ask as many questions as you can. Back to you, Dewey.
Sure, thanks. Thank you. Yeah, so I think we are going to start with Mr. Abhijit Banerji. I will just try to share my screen now. So Abhijit, sir, you can go on.
Yeah. So what I'll try and do is I'll try and share with you what is it that Government of India is trying to do in the wastewater treatment space, and what is it that and why do we think it is important, and where does it really fit in the larger game of things for Finnish society or top trust, and what is it that Finnish society has been able to do in the past couple of years. So just to give you, and what I'll take a cue from what Valentin just now spoke about. The Government of India has got two flagship programs at the moment. One is Jal Jeevan Mission, and most of my team members are aware of this particular program, I'm sure. But then just to refresh it for everybody, including those who are not from India. So Jal Jeevan Mission is about providing piped water to all rural households, and in it the government has also provided for, because it realizes that the challenge is not only about providing water but also making water available, and that is increasingly a big challenge. And I was about a couple of days back at a meeting with ISC FICCI, the India Sanitation Coalition meeting, and there one of the things that I was talking about and sharing is the hotspots that the country has, right, which would mean that the way groundwater is plummeting. The other program that we have is what is called SBM Phase 2, wherein what the government is talking about is ODF plus. So ODF has been declared by the government at the end of SBM Phase 1, Now, for the sustainability of the program, it has come up with ODF++, which covers solid waste management, fecal sludge management, and also grey water treatment in villages. So it's a very detailed program with budgetary support, and which means that there is an opportunity for the development sector. Shall we move to the next one? And when we talk about gray water or wastewater that is generated, so there, 2007, UNICEF and Ministry of Rural Development, Government of India, estimated that anything that India generates about 15,000 to about 18,000 million liters of grey water per day. But I was reading a recent article by that CSE publication called Down to Earth, issue dated 24th of August 2023. And there they are saying, CSE says that somewhere around 31 million liters of grey water is generated every day. And their estimation is that this, if only 50% of this water can be treated and put back for use, then a large part of the water shortage that is there, that can be covered. And here also, in that particular report, which I earlier talked about, Ministry of Rural Development and UNICEF, they say that 90% of the total water supplied for domestic use generates wastewater, that if treated could be used for agriculture purpose, and which could save also money. Next. This is the one that I was talking about, and increasingly, and something that we are also seeing in our project areas. I remember having being in touch with some farmers, of course, way back in Kapurthala, and they were talking about that Kapurthala is Punjab and mainly an agrarian belt, that groundwater is increasingly becoming a challenge, and because it is increasingly going down. And in fact, the area where I stay, Gomti Nagar, so there also in Lucknow, so people are complaining that some people have got these submersible pumps, and they're becoming non-functional across areas, across large tracts of India, northern India, and of course I'm not so conversant with the southern India, but then there are large tracts wherein water availability is increasingly a challenge. And this is when you see that multiple Government of India has already flagged that there are multiple red flags over groundwater exploitation, particularly in the north. So Punjab and these Haryana, these places which are so-called the rice bowl of India. So their water availability is increasingly becoming a challenge, and agriculture is becoming quite expensive because people have to use the pumps, diesel pumps, and which means also that their cost of cultivation is going up. Next. Which brings us, this is on the one hand a problem, but also an opportunity for a development organization like us for Finish, and that Finish with proper models and approaching the problem correctly with the capacities and the reach that we have, we can try and make some difference to the problem that is being faced. So we have tried to develop some capacity building tools. We have been trying to approach this from an appropriate solution perspective. So our aim has been and is that solutions, technology that we look at should be, and here I'll quote Anand sir, from whom we have picked up whatever we know, is that solutions have to be low maintenance. So we look at appropriate treatment systems, and some examples of that I'll share later. And then once these systems are set up, also work on the operating and the maintenance of these systems, so that merely getting the infrastructure in place is not good enough, but that it functions smoothly. And then finally, of course, monitoring the results by looking at testing the end output. And sometimes it also requires tweaks and improvement, so that the quality that we get is as per the need of the customer. Next. So this is how we approach a particular challenge. So we do a ground assessment. Huh? Okay, so we do a ground assessment, and some examples of that I'll share when we come to some of the work that we have done, looking at appropriate technology options, and along with that, of course, also address social and social issues which are there. Because like what happens is that we were doing this project, Greywater treatment in Dungarpur, Rajasthan, and the challenge that we faced was that people were throwing plastic bottles and whatever waste that they had into the wetland that we had created, which we addressed, and by bringing in people, by mobilizing the shopkeepers in that area, so that they started acting as guards for the infrastructure that had been created by us. Selection of land, this typically is done together with the urban local body or the Gram Panchayat where we work, and which means that we have to obtain also legal and NOCs from the administration, because land has to be allocated for these solutions, these treatment plants that we are talking about. We typically don't do hardware financing, so obviously government institutions, government resources have to be leveraged for that. Design is always, and which aligns with what I was talking about earlier. So selection of appropriate solutions. So accordingly, these designs are finalized. And to give you certain examples, we were doing a treatment system in Ponampatti, that is in Tamil Nadu. And when we began the program, we had designed it for only grey water, wastewater from that town panchayat. But when we did a testing of that, we realized that it also contained black water. So the design that we had made had to be adapted, and we had to change it and address the challenge that was found. Something similar I'll also share with you when I talk about one of the treatment systems in Rajasthan. Then construction of treatment system, including test runs. So you set up the system, you try it out, then test the output water, and then it again goes back to the design stage, make the necessary required changes. Operations and maintenance systems have to be tried out. Supervision we typically do for a couple of months, and in some cases, for example, in one of the plants that we have done in Rajasthan, government, the urban local body, also entrusted us with the maintenance of those systems. So that's how we carry out such projects. Next. We typically evaluate a project in terms of return on investment and end-use purpose. So I'll elaborate on particularly this end-use thing. So when we take up such initiatives, we try and see that what is the client looking for? That is, what the water is going to be put to what use? Is the water, post treatment, will it be used for drinking, or will it be used for agriculture, or will it simply flow into the pond, into a lake, and over a period of time that water will get regenerated? So the treatment systems that we design, we try and do it keeping these factors in mind. And along with that, we also try and address the overall cleanliness and aesthetics of the project, because then what happens, the government and the community, the acceptability and the maintenance of such units are much better. This, if you see, is one of the constructed wetlands that we did for Sonaria. So here, this plant has a capacity of 50 cubic meter per day, and we did this. This was one of our initial plants that we did for an urban local. It's a very small municipality in Rajasthan, and one of the interesting aspects of this is, if you look at this, so the part of drainage, grit chamber, grease trap, and the collection cum equalization tank is on one side of the road, and the horizontal roughing filters and the HCVL, the horizontal constructed wetland, is on the other side of the road. The simple reason being that land was not available, which happens, and particularly in the north, because availability of land is quite a challenge. And here what we had to do was that we had to put in a pump to transfer water from the equalization tank to the roughing filters. However, it has always been our endeavor, and always, I suppose, also going forward, that we try and do systems which do not have, or we try to avoid to the extent possible, mechanical or electronics equipment in the program. We try and do nature-based systems, simply because the maintenance can be or would be much lower. It is easier to keep and run. Shall we move, Juhi, to the next one? So Gabe Sagar was an interesting treatment system that we did. And here, when we did the testing of the input water, what we came across was that the water contained some overflow from a dairy plant. So the treatment system required some additional parts to be added, and that's why here you see that there is, unlike the Sonaria system, which only had the equalization tank with the roughing filters and the horizontal constructed wetland, here we also added an aeration tank, and from here the water flows into a secondary tank. And what we do is that on a periodic basis, we transfer some of the sludge from the secondary settling tank back to the aeration tank to maintain the microbial load. So this particular plant requires a manpower to be to be there on a periodic basis at least, so that this transfer of sludge and the aeration tank that we have, so a pump is installed there for the operation of these things. So here there is some kind of an OPEX involved, a manpower is required here. Unlike the first one, wherein a pump which is there in the Sonaria, but then that is more easily maintained and operated, and we managed to get the local one of the shopkeepers there to help manage the operations there. Here, since it also entails transfer of sludge, etc., so we had to put in, the municipality put in a manpower. Next. The very simple system that we did, this is a project that we carried out for the National Stock Exchange Foundation. And this is a typical challenge that households in India face. So like the wastewater from cloth washing stations, households, every village or most villages, if you see, it tends to accumulate. So what we try to do here is this, that we put in these small solutions, and this is a residential school, what are called ashram shalas in Nasik. So there, this particular small treatment system we had put up. So then the water does not accumulate everywhere, and gradually the water evaporates, and this is something that we tried out there. And here again, there is the same technology. So evapotranspiration we used in again a Nasik school, ashram shala, and there you see the pipe. And what was done is these pipes are perforated, and since the soil does not the water does not percolate so easily, this is the black cotton soil over there, and the perforated pipe, the water flows out and spreads over the gravel that has been there. And to aid the process, we employ these water consuming plants. So banana is something which is quite popular and very effective, and it also gives, since it also yields fruit, so it's much loved by the community there. Another solution again Nandurbar, and there we did this soak pits. This is for these kind of solutions we did for the hand pumps that are there. So hand pump, some water is always wasted and tends to flow all over the Gram Panchayat. So here we did these the soak pits, which would take the water and ensure that the area was kept clean. This greywater treatment that you see in Srirampur, this had a capacity of 4 KLD, and it comprised of a rock filter, a roughing filter, and a small constructed wetland, constructed at a cost of 2.5 lakhs. And this requires no maintenance, almost zero maintenance treatment system this was, and the output of this was sent to the nearby farmers. Frankly, please don't ask me about what is magic about this, because it's merely a soak pit, and there the idea is that the community wastewater that is there, that is generated, that flows into these pits and to keep the Gram Panchayat clean. So this was done extensively in the project area, and under the new project that most of my team members would be familiar with, the Lighthouse Initiative. All these solutions are quite popular, can easily be adapted in those territories. Thank you.
Yes, thank you so much. So then we'll start with Dr. K.V. Emmanuel's presentation.
Yeah, good afternoon.
Good afternoon, sir.
Can we hear? Yeah, that's fine. So I will take off from the point where Abhijit has already mentioned. Let's start with why this greywater reclamation is important. I will try to give a different perspective to it. As you all know, availability of water in India or all developing countries have become a major issue. And one thing we of late noted that it is a major criteria in purchasing a property in urban areas. In many of our cities, the locations which has got enough water fetches a better price compared to the other area. Because now that is one of the major consideration of people, because the water is getting scarce and scarce. Now, many of these cities in India now has got a better coverage of sewerage network. And I would say this has got a major role in higher water depletion. This may look very, I would say, controversial and paradoxical. Why we are saying, on one hand, we say we have a better sewerage network, which is an indication of development. On the other hand, I make a statement saying that that has contributed to our water scarcity. I would like you to look at it in a different perspective, because think about our olden days where we have the water being used in our houses and the wastewater is taken to kind of a septic tank, and at the outlet of septic tank it goes into a soak pit where it joins the underground water. Today what is happening, we have got the sewerage network. So what happened, we use the water, it goes into the overhead water tank, and then it is being used in the house, and then it comes out and gets drained into the sewerage network. And what happened to that water? That goes into the sewage treatment plant, and from there it goes to the final disposal point. In cities like Chennai and or Mumbai, it goes to the sea. In earlier case, we used to get back almost all the water, except maybe what is lost during the cloth drying or the perspiration. Almost all other water used to come back to the ground. And of course, it was traveling through the soil network and was reaching our drinking water intake point. Definitely, it also reaches the intake point of our drinking water. But what used to happen, the soil microbes used to purify that water which comes out of septic tank to the extent that it is fit for our human consumption once it reaches the intake point. So when the city started growing vertically and the water discharge became higher, we started connecting it to sewerage network. Now that water is invariably lost. Now in city of Chennai alone, about 800 million liters of water is lost every day. And Mumbai, Delhi, everything is similar. Now imagine we are having something like 10,000 half an SP pumps, pumping the groundwater and pumping it to the sea. How much water will be lost, and no amount of water conservation is going to make up for that. So this is what I said, this improved sewerage network has also resulted in higher water depletion. In Europe and all, it doesn't really matter because the water is also centralized in supply. It is also discharged in a centralized manner. Wherever we use groundwater, this is a problem. So what can be the remedy? The remedy is that we need to somehow treat this sewage water and use it for groundwater recharge. There are two options. One is a conventional treatment where we have got these aeration tanks, fluidized aerobic bed reactor or MBBR, and then use it back for after disinfection. The second option is to go for the nature-based systems using constructed wetland. Next. So let me say, of course, when I say disadvantage of conventional STP, I don't mean that conventional STP is bad in any manner, because as I mentioned in the beginning, most of my projects are in conventional STPs. But when we talk about in a decentralized level, it has got a very big disadvantage, and I could see about 80-85% of our sewage treatment plant network in India is not working satisfactorily. This is what I have been discussing with our Honorable Environment Minister a month back, where we had a meeting in Delhi. So he was also very concerned and he has shown a lot of interest in looking at appropriate solution through nature-based system. In fact, he wanted to try that in his place in Haryana as a model plant, which they are now currently discussing. So these are the disadvantages which we discussed. One is any conventional STP need trained operators. You have to operate it completely on a continuous basis, 24/7. And also it needs aerators, artificial aeration. So that means higher power cost. And another important point, which is more important in area where there is a power cuts and power failures, is that conventional STPs require continuous power. If there is about 4 hours of power cut, then about 50% of the microorganism we cultivate will die off, and it could create a major problem. About 12-hour power failure will result in collapse of the system. So this was a major disadvantage when it comes to STP, and it also produces some surplus sludge which needs disposal, and it of course needs continuous operation. And if it is not operated properly, it may generate some order problems. Next slide. So I was just saying conventional STP, when we compare it with a constructed wetland-based STP, for a capacity of, let us say, about 25 cubic meter per day. Let us say conventional STP and the constructed wetland. In the capital, it is similar, and maybe the PWL may be a little higher. But the operating cost difference, you could see there is a big difference. It is only a fraction of that, and efficiency is high in both the cases. And another important point about the conventional STP is that it is very poor in removing pathogens. In fact, we use cultivated bacteria in the conventional STPs. So most of them need disinfection after this thing. Whereas the reed beds, I may use reed bed in place of constructed wetland because that's a term which we use very frequently. And there the pathogen removal is pretty high and operation maintenance is very low. And the sludge production also is marginally very little and much lesser than conventional. And it has got a high removal rate of nutrients, especially nitrogen and phosphate. This is important when we have got the wastewater is discharged into a lake or a pond or a river, where the nutrient can create eutrophication. So the reed bed is a better solution for that. And of course, there is very little chance of water nuisance from the reed bed. Next slide.
उसी में जा रहा है.
So what are the advantages? We say, first of all, it is very aesthetic in appearance. There is no need for skilled labor, no chemical or any big maintenance is required. There is no sludge production. There is no odor nuisance. Basically because the odor will come if the water is stagnant over the top. In a properly designed reed bed, the water stays always below the level of media. You won't see any water stagnation at all. The water does not come into contact with the air until it comes out as treated wastewater. So there is no chance for odor nuisance or mosquito breeding. So this is one of the major advantage with respect to reed bed. And there is no need for continuous power. Maybe there is a need of one pump. This can operate in batches and very low operational cost, as I already mentioned. And there is a flexibility in operation. Suppose the flow rate becomes very high occasionally. In a conventional plant, it becomes very shock loading is a major issue, whereas in a reed bed, it can manage a big shock loading anytime. And also, suppose there is a flooding in Chennai, some 3-4 years back, there was a big flood. And many of our sewage treatment plants became out of order in one time, whereas this reed beds which we constructed continue to function. For about 2 weeks, it was underwater and nothing happened to that. So that is much more flexible compared to the conventional plant. Next. So basically, this is the scheme of the reed bed based treatment. You need to have a screen. The screen can be very small, a very coarse screen, because the basic function is only to remove major things like a gunny bag or something large enough. And then an anaerobic tank. Basically, you could see from the design that it is an extension of our septic tank. And then the constructed wetland, which is the reed bed. And afterwards, it can be taken to a pond where it can be either taken for a reuse or it can be used for recharge of this treated water. Next. So the units, as I mentioned, the first stage after the screen can be an anaerobic tank, which essentially digests the solids. The solids settle in the tank, and over a period of time, it will get digested. So in a normal septic tank, you need to remove the sludge maybe once in 5 months or 6 months. Whereas in this kind of a unit, it may take up to something like 2 or 3 years. You need to remove the sludge only after that, because it gets digested over the period. And the unit usually provides 50% removal of BOD and about 45 to 55% of COD. And you can already modify it with a constructed civil structure, which is basically the septic tank. You can construct it as an extension. Next. The units of the reed bed is that you need to have a media, and then you need to have a plant top on it. Usually we use reeds, even though any kind of a plants can act. We normally prefer something called reeds. You could see on the right hand side picture the stem of a reed. You could see it's a hollow stem. The reeds are generally capable of transporting the atmospheric air. Through its roots, it can disperse into the water. So because of that, some aerobic condition can be maintained. We can say it is a natural aerator without using any power. It supplies some oxygen through its roots, and the bacteria grows around that roots and the media. And the reeds which are normally used, which has got the highest efficiency, is an Australian variety called Phragmites australis. But in many of our plants, we also used a flowering plant, Canna indica, which is used mostly in gardens. And one thing I would like to stress here is that many of the people who promotes the reed bed also has got a misunderstanding. They think that the pollution is removed by the reeds. Like any plants, it absorbs the organic matter, and that is how the water is getting treated, which is totally wrong. The actual absorption of nutrients and carbon, that is organic matter, into the reed is only 10% of the total BOD and COD removed in this system. Otherwise, it works just like any other conventional organic, conventional STPs. In a conventional STP, we use microorganism, mostly something like Pseudomonas. The same kind of Pseudomonas is acting in this reed bed also. The only thing is the aeration here is provided naturally by the reeds instead of an artificial aeration. Next slide. So we will go through a few of the case study. I will start with the very small plants, small grayscale plants, greywater recycling plants, which can be for any capacity from maybe 200 liters to maybe 30,000 liters. It can be done in such a scale. Basically, the water recovered can be used for gardening and for groundwater recharge. The common scheme is a septic tank and then an anaerobic reactor. You can also combine these two. and can be a reed bed, then if needed, there can be a polishing treatment. For example, if we are using the recovered water for toilet flushing, it will be better to have a fine filtration and disinfection. Otherwise, it may not be required. And most of the reed beds for such small units use Canna indica, and some few case studies I'm presenting here. Next slide. See, this is a very small reed bed, which has got a capacity of only 500 liters per day. This was taken at the time when it was planted. The cost was only 35,000 Indian rupees. It was in 2010. And we got a payback of about 2 years and a little more, 26 months is the payback period estimated. And the other benefits is it can be a part of the garden. Next slide. So this is in another residence in Chennai. I'm giving only a few case studies which are there in Chennai. We have altogether, I believe, about 30 to 40 such units running. And I have taken those units which are operating more than something like 10 years in a period, because just to say that these are resilient and sturdy units. This unit is having a capacity of 3,000 liters, and the payback was about 28 months. Next. This is another unit which is in Bangalore. This is in a college, and the capacity was 14,000 liters. The payback period we got was about 8 months. Next. This is another residential unit in Chennai, where it was 3,000 liters per day was recovered like this. And it is running for about 14 years now. And you could see after 14 years, it looks like this, because we have taken this photo only some 2-3 months back. The difference here is that here, unlike other plants, instead of Canna, that's a flowering plant, here they have used the Phragmites australis, which is the basic reed. And the payback period was 22 months. Next. So this is another reed bed unit in Bangalore. Next. So this is yet another residential unit in Chennai, where it was installed in 2012. And it got a payback period of about 22 months. Next. So this one, I have estimated a payback period of 7 months. It is a capacity of 1,000 liters. So it was installed in 2005. The interesting point here in this is that it is in my house. I maintained that system till 2017, about 12 years. And I had to stop using it for I would say a weird reason. And the reason is that I was using this water recovered from this typical reed bed for irrigating my lawn. So all my housemates used to think that that is a groundwater which I am using for the irrigating the lawn. One time, what happened? The housemaid who came there started using this water to wash her face, because the water looked so clean. She started washing, and I have started saying that please don't do it. But she continued to do that. One time I had to tell her that, look, this is not groundwater, it is the recovered wastewater. And she got a big shock. And then she said, oh, I started getting itching here and there and on. So to avoid further issues, I had to stop it. That is why I said it was a weird reason why I could not continue. But from 2005 to 2017, this was my source of water for my garden. Next. So now let's have a look at the case studies for large-scale greywater recycling. So basically, it has got the same scheme. You need a collection tank and a baffle reactor, and then a reed bed and a polishing treatment. If the use involved any contact application, like any kind of a washing and all. The application which I mentioned in what is proposed for Haryana by our Honorable Minister for Environment, Mr. Bhupendra Yadav, that one he wanted to use this water for a temple pond where people will wet their feet. So I suggested that in such a case, there may be a need for a disinfection. Otherwise, we can use it as it is. So I will be giving a few case studies, which is again operating for a minimum period of 10 years. Next. So the first one is Aravind Eye Hospital in Pondicherry. It is a very large plant, I would say, in terms of reed beds. You say it is treating 450 kiloliters per day of wastewater. And one of the reasons why they wanted to go for it is that there is no proper disposal facilities for sewage from the hospital. So they wanted to reuse. And they have gone for this constructed wetland of about 2 acres with Canna indica as a plant. You can see it in the first picture. And the unit has been installed in 2004 at the cost of about 90 lakhs. A conventional plant would have cost about 70 lakhs for the same purpose. And the operating cost for this plant is about 3 rupee per cubic meter, whereas a conventional plant, the cost would be about 16 rupees. That means a saving of about 5,850 rupee per day, which translates into 1,75,500 rupee per month or 21 lakhs a year, which means the payback of additional cost was done in less than 1 year. This has been commissioned in 2004. And it has got a much better aesthetic appeal. And one important point about this plant is this has been inaugurated by the Honorable President of India at that point of time, Dr. Abdul Kalam. Kalam was actually a faculty in Anna University before he became the president. And I was maintaining a close touch with him. So when I mentioned about this project, he was offering himself to inaugurate this project. So he inaugurated this project. Next slide. You could see a few photographs of the thing. This is the photos of the baffled reactor. You could see all of them have been constructed underground, where they use this space as a parking ground. So there is no loss of space. Next slide. So this is the photo of the reed bed. You could see it is right in front of the hospital. In fact, you could see there is a gap between the two reed beds through which people used to go to the reception. Of course, if you are coming by the car, you can go directly to the reception. Those people who are coming after getting down in the bus stop has to pass through this area. Next slide. So you could see this is the water which is recovered from this plant. And on the left side, you could see a small bridge. That's what I mentioned. All those people who are coming to the hospital has to pass through that bridge. They never knew that they are actually passing through a wastewater treatment plant. Next slide. Now, this is the aerial view of this pond and the reed bed. Now, the interesting part is that for the last, it was installed in 2004, I said, last about 20 years, that unit is as good as new. It is functioning even today. Anyone who is visiting Pondicherry, this would be a good visit. Next slide. And this is another institution called RVS Institution in Coimbatore. They have got engineering colleges, dental college, and many of them, and they have got hostels, which was generating about 150,000 liters per day of sewage. And they wanted to reuse this water. And we have gone for this reed bed system, where Phragmites australis was used as the reed, because it's the backside of the hostel. And the cost was about 60 lakhs. And at the cost of about 3 rupees per meter cube of operating cost and 18 rupees as a freshwater cost. Actually, the freshwater cost is much higher. But I was saying that even if you go for a conventional plant, you would have been spending about 18 rupees per cubic meter. So just comparing that, without even taking the recovered water benefit, you could say the payback period is about 15 months. Next slide. This is say overall look of this thing. You could see it all look like a kind of a forest area. It is not a forest area. It is in the middle of the city. And you could see the reed which is there is the Australian variety, Phragmites australis. Next. This is again another view. You could see how dense and lush that growth is. Next slide. So I will also mention another reed bed, which is there in the university where I was working earlier as an advisor. That is how Dr. Kalam get involved in this thing, because I worked as his successor in Anna University as a technical advisor for some time. So during that time, we wanted to use bag the sewage, and we put up this unit. The Anna University campus generate about 300 cubic meters of sewage, and we were recovering about 100 cubic meters of sewage using this reed bed system. And that is there, and it's again the operating cost was about 3 rupee per cubic meter. Next slide. This is the view of the reed bed. You could see here also the plantation is so lush, green. Next slide. It's another view of the reed, but you could see behind that there is a Madras School of Economics as a faculty building. So this is right in the middle of the city, and it gives you such a green appearance all around. Next slide. So this is another a typical unit where it is being used for recycling of sewage in a club. Madras Club is one of the oldest club in Chennai, where they were generating about 35 meter cube per day of sewage. Now, the one interesting part here is that they had no issue with the sewage because they were connected with the city sewerage network. All their sewage was discharged there. So they had no issue at all. So how this plant was created was one of the time when I was sitting there, I could see that there some tanker lorries were bringing water into the club. So I asked the president of the club, why are you taking water in tankers? So he says it is used for irrigating the lawn. There is a very big lawn where there is a jogging track, and all the CEO of major companies in Chennai used to be the regular visitors there. So they wanted to maintain the lawn very green. So they were getting water in tankers. So I suggested to them, why don't you go for a sewage recycling system? They were very reluctant. They said, no, it will create smell. Why should we take a risk like that? Then after some time, they got convinced they wanted to go for this recycling system, but they wanted to locate in the corner of the club. Then I insisted that no, you cannot have that. You have to have it there, right there in the club, around the smell, they will bulldoze it. And finally, they implemented that unit back in 2003. And the capacity was 25 meter cube per day. And the cost was about 2 rupee per cubic meter. And they got the entire investment paid back in 22 months. And even now it is working after so many years, almost 21 years later. It is still working quite as good as new. Next slide. So here you could see how it has been planted. No, sorry, it was not in 2003, it was in 2005. I'm sorry for the error. So it is 19 years now. So when it was planted, it was in January 2005. You could see it was quite dry. And after 1 month, it started coming up there a bit higher. And in March, it came up to, say, almost 2-3 feet high. And by April, it came as a full-fledged unit. And by May, it getting to the full level of treatment and growth. Next slide. Say here you could see the reed bed, and you could see what you see on this side is the jogging track and the lawn, which I mentioned already. Next slide. This is the close-up view of the reeds, which is again growing very lush. Next slide. And here you can see somebody is measuring the height of the reed bed. He looks as young as he is now, but back then something like 2007. Valentin, you never age. You look the same all the time. Okay. You could also see on the right side the clarity of the recovered water. You could even take it on your hand and without any issue. Next slide. So I will finish off this case studies with one project which is now ongoing, which is a purification of sewage which comes into a lake. The lake is called Shembakam Lake. It is in heart of Chennai city. And the sewage which comes to the lake is very high, very big, almost 7 million liters, 7,000 cubic meter per day. And an NGO from America, that is a TMC, is focusing on the rejuvenation of this lake. And one part is the sewage treatment before the sewage is admitted into the lake. Why the sewage need to be admitted into the lake instead of diverting? The reason is it is landlocked lake where there is no perennial supply of water to the river. So to counteract the evapotranspiration, you need to allow the water to come to the lake. So the only option was to treat the sewage and allow that water to come to the lake. So it is a unique experiment, and they have taken the Finnish consortia, where my company and the Finnish India joined together along with Mr. Anand from Solution Center. We were jointly is a consultant for this project, and we have suggested a constructed wetland. Here there is one interesting part is that the stipulation of government is they will not allow any concrete construction in the tank, number one. They will not allow any material to be taken out or brought in. Like that, there were a lot of restrictions from the government. And also they wanted the O&M cost to be the lowest. So it was quite a big challenge. And we came up with a design involving one aerated lagoon, because you cannot have for 7,000 cubic meter, you cannot have only reed bed because the area will be too big. So we have got a small aeration pond, which is not in concrete, which is actually a kind of earthen pond, and then the reed beds. And the investment cost is about 3 crores, and the O&M cost is about 2.5 rupee per cubic meter. And conventional STP, the operating cost could be about 12.5 rupee per cubic meter, and we have got a payback period estimated for 15 months. So this plant is under construction. You could see in the next slides. See, this is the aerial view of the lake. You can also see the plan of the lake on the left side. Next slide. And these are the progress of work in the Shembakam Lake. Next slide. So you could see this is the design which we are given. We are given reed beds on the side of the lake as a part of the lake itself. You could see in the middle picture, you could see the landscaped view of our reed beds. On the right side, you could see the media being filled. Next slide. Next slide. Here you could see Valentin coming and inspecting this place. I think that is some 1 month back, last month. Valentin, the first set of reed beds are ready for planting. We are going to plant it next month, and maybe by November, we expect this plant to be commissioned in full. Next slide. So now one of the question which could be there in your mind is, see, I was saying that all these units were operating for more than some 10 years, 15 years. It was all operating for such a long period. It has got all the advantages you can think of. Very low operating cost, low maintenance, no smell, and easiness of treatment, very high efficiency. Then why it is not so popular? There are three major disadvantages of this. One is that it needs much more area. It needs about maybe 5 times of a conventional STP. And it is the major reason why it is not popular is it is not attractive to most of the contractors who are constructing sewage treatment plants. Basically, this is having only civil work. So any civil engineer from the client side can estimate and say that this is a cost. Whereas in a conventional STP, what happens? The contractor supplies some pumps, he supplies some aerators, he give a bill and nobody question him. In this case, they will say, oh, what is, why it is costing so much? In fact, I was witnessing one case where a typical client was saying, oh, you have supplied some stones and some wild plants, and for that you need 30 lakhs. What is this? So the same guy would have given easily this 30 lakhs to a conventional STP contractor without even battling an eye. So here, this is one disadvantage which most of the contractors of sewage treatment plant doesn't want to have reed bed as their supply. And very interestingly, it needs a lot of engineering. This is where many of the NGOs, you may also might have heard the story that some of these reed beds which have been put up there in some place were not working, it was not giving good result and all. One of the reason is people do not understand reed bed needs very precision engineering. To keep it simple in operation, you need to design it properly. So here you have got a bed where in which you have got the roots of the reeds distributed all around, and to get the treatment, you need to distribute the water equally throughout the bed. For that one, you need to have the flooring very precisely leveled. You need to have the outlet of the reed bed to be exactly in the same level. Otherwise, what will happen? The water will start passing through only one portion of the reed bed, where the efficiency will drop very drastically. It needs a very high level of engineering. So this is something which we need to understand. And management of this disadvantage, you can say the space wise, in most of the area, you can integrate it as a part of the garden. Even otherwise, many of the rural areas got FSI restrictions where the government do not allow construction in certain areas. There, I think the reed beds being not a conventional construction is allowed. So I think we can use that space for constructing the reed beds. And for that underground tanks, you can always cover the tank and use it as a car park and something which you have seen in the case of Arundhati Hospital. And the entire area will be appearing as a green belt. So this is going to be a very promising thing for us if we really plan integrating it with our constructions. Next slide. So what is the way forward? So in my opinion, every individual house, we should have this kind of a decentralized system, because not only that we can use the water for irrigation and toilet flushing, you can be assured that your groundwater table will be always maintained. So I could give you one example in my house. I could say I am staying in that house for the last from 2003 onwards. I have never got the groundwater table going down, irrespective of the fact that my neighbors still use the water in big quantity. I still maintain the quantity because almost the entire water was coming back. And if there was no much usage for gardening, etc., you can use it for groundwater recharging. And the hotels or hospitals, they can use it for what you call toilet flushing, etc. And this is a good option for recovery of sewage because of obvious advantage like no power, chemical or manpower. And it also add up to the aesthetic appeal. So let us all try to make a kind of an effort by putting up this recycling system through this kind of a system. And I believe Finish will be always taking it up as a champion of this kind of a system. Thank you so much. Over to you, Jeffrey.
Thank you so much, sir. Thank you. Very interesting. It was very, very nice. Thank you so much. I think we will now move to the questions. I will just stop sharing now. Yeah. If anybody has got questions, you can either, unmute yourself or you can also write on the chat box.
Thanks. Maybe it's always nice to be the first. I have a couple of questions for you, Emmanuel. Number one is on using nature-based as compared to conventional sewer treatment. There is, next to the savings you're talking about, there's a climate impact, right? Have you ever tried to get the CO2 savings for a nature-based system? Have you compared it with a conventional treatment system? And what is the ballpark figure? You give nice figures for this, the ballpark for O&M, this is the ballpark for investment. So that's the first question. I'm just going to ask three. So number two is you talk, and again, I find it very fascinating. You talk about reed beds as being an excellent way of getting rid of eutrophication. Now, when the few times I go into a village in North India or in Bangladesh, most of these village ponds are very green, meaning the eutrophication levels are pretty high. And so it could be a very good treatment in that sense. But what would be your suggestions for O&M? Because it is a low maintenance system, but it's not a no maintenance system. So what would be your ideas? And then the third one, that's more maybe like an idea. I don't know if it makes any sense. My understanding from the constructed wetland, a lot of the money goes into the media, so the filter material. So are there options, you think, for starting to reuse different kind of waste products to act as a media? And from Sri Lanka, I remember that we used, at least on a pilot basis, we used broken roof tiles, but you can maybe think of others, and that could significantly reduce the cost, perhaps. So three big questions. Let me stop here. Thanks. But I liked your presentation. Thanks a lot.
You should remember that my memory is very short, so I may not remember all the questions. So if I miss anything, please do not hesitate to ask again. Now, the first question is related to the carbon footprint. Now, honestly, Valentin, we never made any kind of comparison. One of the reasons why we did not make this comparison, conventional treatment, if we keep out the electricity requirement, there is a big difference in carbon footprint. If you consider the power requirement, there is a big difference because conventional treatment requires a lot of power. But the other point of carbon emission in terms of carbon dioxide is from the treatment itself. For example, whatever organics we are sending there is getting converted into carbon dioxide and water. So there is an emission of carbon dioxide from the system. But here, that carbon dioxide emission will be more or less same in the conventional system as well as reed beds, because in both the cases, the product is carbon dioxide and it goes to the atmosphere in equal measure. But there is a difference because of the power consumption. The carbon footprint of reed bed is much less because it consumes very little power. Anyway, it is a very good suggestion which you have made. I will make a kind of a comparison and try to project it next time. So far, we did not make that comparison. The second thing about the eutrophication. Yes, it is a very, very interesting part, and I believe we will get a kind of first-hand experience from the Sembakam Lake project as a model, because that lake is highly eutrophicated right now. So after implementing this project, we will get a demonstration which is clear to anyone from outside. I think compared to the conventional treatment or no treatment, the situation will be at least 5 times better in terms of nutrient removal, basically nitrogen and phosphate. So the eutrophication will be just about the chance of eutrophication will come down by a great extent, some 10 to 15%. It will come down to that level. So I was saying that one which you may not even notice, the normal algal growth, you may not even notice if you put it up there. So that this is a very good option for that. And what was the last question related to? Sorry, you have already seen. Okay. What was the last one?
So actually the second question was on for village ponds, right? So
Yeah, then you
some
were talking
bottom
about
lake
the media.
larger.
Okay. Yeah,
So
sorry.
what would be the order? So this was the second question. The third one is to change the media
That's right.
from this gravel to something else.
Actually, you can use any material as the media as long as, number one, it gives a decent pore size area, pore size view. That means the size of the media should be small. Let us say 2 to 4 millimeter media should be good. And second requirement is as much as possible, the media could be round instead of having any kind of sharp edges. It could be good if it is having a reasonably kind of a round shape. But you know, it is getting a media of that kind is ideal, which is going to be very difficult. In the first read bed, which we tried for the ternary effluent, of course, that is an initiative of Mr. Post only. So there we tried the pebbles, which was fortunately it was available as a waste material nearby. So that kind of a material will be much better. In later reed beds, we used to use the blue metal chips. I won't like the name blue metal chips because people may get confused. What is metal and all? This means broken rubbles piece of 2 to 4 mm, because that is the cheapest material. Now you are right, we are in search for a good media at a cheaper cost. And one of the things which we are right now considering is that there is a byproduct of an plastic extrusion plant, where they produce some pellets, round pellets of plastic as a waste material. We are currently evaluating that. So if it works out, I think that could be a good media. But otherwise, we are still in search for a good media. It should be cheap, it should be of smaller size, and as much as possible, it should be round in shape. Thank you.
Thanks, Emmanuel.
Okay, so we have a couple of questions on the chat box. One is
Okay.
from Mr. Henk Holstad. Sir, would you like to, question yourself, or should I just read it out? He's asking about.
You can
Yeah,
read it
yeah.
out, yeah.
Okay. So he's asking about, what is the maintenance that these plants like reeds need, and does it have to be cut sometimes? If so, how often?
Yeah, that's a very good question. Normally, you need a very little maintenance, as I mentioned. But the reeds, there are two kind of maintenance being done. In some case, we do not cut the reeds at all. We just allow the reeds to be there, and it dies, and a new reeds comes in their place. But obviously, you could see it will look a bit clumsy when you look at the plant. And also there is a light possibility that the material which falls into the surface may eventually form some clogging in the bed later. So in maybe 50% of the plants which we have mentioned here, we used to cut the reeds at an interval of about once in 6 months. And that cutting is done more in the plants where Phragmites australis have been used as a reed. The basic reason is this: there is a ready-made use of that one. In India, especially in villages, they use this Phragmites australis leaves to make mats. So it is a good raw material for them. So they come and cut it. They ask for our permission and cut the reeds, and it grows in no time. As long as the root structure is intact, it grows in something like a 2-3 weeks time. It grows back again. But even if you do not cut it, we do not see any drastic reduction in the efficiency. Other than that, the maintenance involved is sometime, let us say once in 3 years or 4 years. It will be useful if we take out the media, wash it back, and put it back again. Or you can top it up with some new media that will increase or retain the porosity. And the third maintenance is required again, as I mentioned earlier. You may need to remove the sludge in the anaerobic tanks. I mean the mineralized sludge that after the digestion, once in maybe 3 or 4 years time. This reed bed in Madras Club, we removed the sludge sometime in 2 or 3 times in the last 20 years. So that is the 3 maintenance requirements are there. But mostly it is very little maintenance. But it's a very good question. Thank you.
Thank you. Very good.
Yeah, we have one more question from Mr. Ashwini Tiwari. That what about situation like wastewater is containing high amount of black water and fecal sludge mixed with grey water and mud?
See, the interesting part is that even though we were discussing grey water recycling in this today's presentation, most of these plants I have shown is treating both grey water and black water. So we do not have much of a segregation. In fact, the presence of black water makes the treatment even better because it contributes to better growth of reeds. And unless you plan to reuse the water and you have got an aesthetic issue in reusing the water, I think there is no problem in mixing the black water with it. Of course, the fecal sludge is a different story. Fecal sludge also, they use the reed bed as a treatment system in some areas, but in a normal reed bed, we do not treat fecal sludge. But the black water is absolutely no problem.
Yeah, okay, thank you, sir. And there is one more by Mr. Rajesh Gupta. He's asking, how could domestic grey water be used for recharging without treating?
I am not saying without treating. No? I was saying that once it passed through the reed bed, you would see about 80% of the organic content in it would have been treated fully. And grey water, when we talk about, there is a lot of detergents are likely to come. And this reed beds, if it is continuously fed with detergent water and also oil from kitchen, if it is continuously present in the water, this system can very effectively remove those things as well. I am reinforcing the word continuously because in some cases what happened, if the laundry water is not connected to the reed bed, and one day if you connect it, then you get a shock load of detergents into the system, which can affect it. But if it is continuously coming, the removal of detergents as well as the oil from the kitchen, the reed bed is an excellent choice. So I don't think there is any issue. Remember, as I was telling earlier, the water was going into the ground without much of a treatment. We used to get only the septic tank. Septic tank is not a very good treatment system. It removes most of the solids, but it removes only 30% of the BOD. And we used to get that water coming to groundwater, and we used to get it into the drinking water cycle even. Now the reed beds can treat about 90% of the BOD. So I think absolutely no problem at all. Thank you.
Yeah, thank you, sir. So there is one more question from Leander Roller. She's asking the question on the residents constructed wetland units. What do you see as the most important reason for residents to invest into constructed wetlands, whether it's desludging costs or recycling options of water or groundwater recharge?
See, I would say all of these three are very important. And I would say desludging comes into the picture only when you actually go for a recycling system. If you go for a conventional treatment, there is a sludge generation which you may need to desludge. And of course, the groundwater recharge is a basic reason why they should consider recycling the sewage, because most of the areas the groundwater table is dropping very fast, and once it drops to a certain extent, there is another reason is that salinization may also happen, and water may become unusable totally. So to give you a small example, I would say some 25 years back, about 5% of the groundwater in Chennai, mostly in the coastal area, was only having salinization. And we were not able to use that water because of very high total dissolved solids. Today, about 23% of the total groundwater which we get in the city has become saline, because the groundwater table goes down and salinity increases. And at one point of time, you will find it difficult to use back that water. So the basic reason why anyone should consider the greywater recycling is for recharge of groundwater. Thank you.
Thank you, sir. Ms. Leandrola, you have any other question following to that? Okay, thank you. Okay, I have a very basic question, sir. I don't know since we are asked that. Yeah, a very basic one. So I was just wanting to know, when you're talking about payback period, sometimes it is 7 months, 22 months. So how can you just explain what exactly do you mean by that?
Yeah, actually, I was considering two scenarios. One scenario is that the value of the recovered water which we use.
Okay.
The second is about the cost saving if you opt for reed bed instead of a conventional treatment plant. Now, if you opt for a conventional treatment plant also, you get the water recovered. So I'm saying when you talk about the value of the recovered water, you need to compare it with the scenario available in that area. And it varies considerably across the country. You know, in a water scarce area like Tamil Nadu, we pay about 2,000 rupee for one tanker load of water, which is about 10 cubic meter. So that means about 200 rupees for about 1,000 liters. We are paying for the fresh water. I won't call it fresh water because the tanker water also is sourced from various area, and often it is as good as wastewater. But not having any water, people are opting for that water. And also the difficulty is that you may not get the water when you want it. Sometimes I have seen the flats are waiting for water supply late night, about 12 o'clock, the water tanker may come and they fill it. Unless you get the water the next day, you cannot have any water for bathing or anything in the house. So having water tanker today is a major thing for many places. So having groundwater is going to solve your issue, not only by saving the requirement of having groundwater transported in tanker, also it is readily available at your housing. And believe me, if the groundwater is not excessively polluted, that's the best source of water for you. because most often it may not need any kind of a disinfection or anything. So that will be the source. So we should look for conserving the groundwater as much as possible. And this is the best way of conserving that water. Thank you.
Thank you, sir. Understood very well. Thank you.
So I think we took a lot of time already, isn't it so?
Yeah,
That is why
yes.
many people are anxious too.
No, I think that's
I
fine.
just asked, can I ask one more question, Emmanuel? So you were talking about constructed wetlands removing nitrogen, right? And if you use it for agriculture, actually, you don't want the nitrogen to be removed. No, you would like it to go there. But you said it also removes what? Did you say sulfur? What did you say that it removes?
Yeah, actually, you're right. If we are using it for agriculture alone, nitrogen is not a problem. It is rather a benefit. I agree.
Exactly.
But most of the cases, what happens? The water ends up either in a lake or it joins the groundwater. In both these cases, excess nitrogen is a problem.
Yeah, okay, clear. Yeah, thanks.
Okay, so I think we don't have any other questions now.
So in any case, Juhi, I would say if anyone gets into a kind of a question coming up, they can put it into the mail. I think you could, you have my email ID, no? So
Yes.
anything which you can forward it to me, I will respond later to you, which you can distribute to them.
Yeah, yes, sure, sir. I think that makes sense. Yeah, definitely. So if we have left with any questions, we can definitely ask them through email. And yes, I will share the PPT also, sir. Yeah. Sure, sure. Okay. Thank you so much then. I think there is just one more question has come from Nahida. Do you have time, sir? Emmanuel, sir?
Yeah, sure.
Okay. Okay, so she's asking whether we can use moringa leaves powder for grey water purification as a media.
Ma'am, I'm sorry, I have no real experience with that, but that's an interesting question. Unfortunately, I never came across this question, but I will certainly research, and if it is really useful, I will try to use it in our own plans. Thank you.
Okay. Okay, so any conclusions, Valentine sir, would you like to say something before we say bye-bye?
Yeah, thanks, Joey, and thanks, Abhijit. You didn't get any questions, but I'm not sure if you mind that much. But thanks, Emmanuel, and now for those who are still with us, to me, a real expert is someone who can also say, "I don't know." And what I really enjoyed, Emmanuel's your last answer, "I don't know." I haven't come across, but I will investigate my own plot. So that's very interesting. What we will do, and Julie has started the process, we're recording all sessions, including the presentations, including the comments, and we'll make, Julie's from the comms as well. So we'll make either a booklet out of it or something or the other. And we'll share it with all those who have participated. So Julie has all the emails. And you get not only the, let's say, the minutes or whatever you want to call it, plus you get the PowerPoints with it. So it's tangible as possible. You can use it as reference material. And secondly, that's my request now to all participants. Think about it, think what you've heard, and see if there is for you a way that you say, this is something we can do. This is what we would like to do going forward. Emmanuel is part of the team, so is Henk. So people who are in this call, I think they would be more than happy to assist. And from a, let's say, more professional point of view, we can always enter into contractual arrangements. We can set up the things. But it's basically, we're waiting for you now to come up with your ideas, your suggestions. And then what we'll try to do as much as possible in the individual systems, we'll try to for systems which are really beneficial at household level, and for the bigger ones, we'll look into different solutions, but all with a view of scaling. So I personally enjoyed the series of 3 very much. Yeah, it's like on water, we should do something on wastewater. We should do something on water conservation. We should do water resource, productive use of water, safe water, you name it. We have to, as sanitation and waste people, we have to move into water in earnest. And to me, and I hope to all the other participants, this series has been very instrumental in giving us ideas and suggestions. And hopefully in the next weeks, months, we'll come up with something very tangible and then look for ways to scale these ideas and these thoughts. So thanks once again, Emmanuel. It was a pleasure as usual, you know that. Thanks, Abhijit. And thanks, Dewey, for facilitating everything. And thank participants for your questions and your time. So I'll say bye for now.